This is a video from the Clock Project. Climate change is warming the oceans, causing a redistribution of species towards colder environments at higher latitudes and deeper waters. These changes vary across regions and are even more evident in biogeographical transition zones. In BTZs, warm and cold affinity species meet. Warm water species are replacing the local cold water species, a process known as tropicalization. In tropical regions, there is little or no replacement for the species migrating poleward, and therefore, they mainly show a net loss of marine species. These changes in species distribution threaten marine ecosystems, impacting food production and coastal economies that rely on fishing. Fishers in fast-warming areas, known as climate change hotspots, are already adapting to these changes. However, we know little about how they respond. Understanding how coastal communities adapt is crucial, given their role in reducing poverty, providing nutrition, and ensuring food security. At Future Oceans Lab, we studied how small-scale fishers are adapting to climate change, focusing on two key theories. Adaptation Pathway. This framework delineates fishers' adaptation along an impact gradient, saying that fishers' responses to climate change go from remaining non-active adaptation to coping, for example, reduce fishing expenses, obtaining fishing insurances, or changing fishing location. Adapting, for example, target new species, use new fishing methods technology, and transforming, for example, start a new alternative livelihood. Migrating, completely exiting small-scale fisheries as climate change impacts intensify. Adaptive capacity. This framework highlights the factors that help people respond to climate change, like financial assets, flexibility, collective action, the ability to learn and act, risk attitude and personal experiences, and the power and freedom to respond to changes. We tested these frameworks in 2 climate change hotspots. Nayarit, Mexico, mainly experiencing species loss. Shikoku, Japan, mainly experiencing species shifts, tropicalization. More than 600 surveys conducted between 2021 and 2023 with fishers in both regions helped us understand how they are adapting to climate change impacts and how their adaptation responses are related to the impact level, or their adaptive capacity. We obtained 2 main findings. Fishers' responses mostly followed the adaptation pathway. The level of impact was a strong predictor for how fishers responded. For example, fishers experiencing lower impacts were more likely to remain or cope, while those facing higher impacts were more likely to adapt. However, when it came to transformative responses, like leaving fishing, adaptive capacity played a much larger role, as these responses often require more resources and can be costly. There were differences in fishers' responses between Mexico and Japan. Fishers in Mexico primarily used coping strategies. They often decided to increase their fishing effort or took loans, as they were dealing with species loss and had fewer opportunities to adapt by targeting new species. In contrast, fishers in Japan mainly employed adaptive responses. Since they were seeing a shift in species, they were able to target new species and invest in new technologies that helped them to adapt. Other socio-economic factors further explain these differences. A. Socio-economic context. Informal employment, often present in developing economies, offers flexibility to Mexican fishers, enabling transitions between occupations. In contrast, Japanese fishers had more access to the necessary economic and fishing assets, which allowed them to acquire new fishing gear and find new technologies. B. Governance and fisheries management system. Japan's fishery cooperatives regulated fishing with territorial access rights, limiting mobility and encouraging adaptive responses like adopting new fishing technologies. In Mexico, the system was more flexible, allowing fishers to move between fishing areas, but offering less support in terms of the resources needed to adapt. Conclusions. Our findings show that exposure level predicts remaining, coping, and adaptive responses, while adaptive capacity predicts transformative ones. Additionally, The social, economic, and governance context shape adaptation responses and can facilitate or limit adaptation options. We observe that there's no one-size-fits-all solution for climate change adaptation in fisheries. Adaptation should be tailored to the unique challenges of each region. Understanding these responses can help us to develop strategies to ensure sustainable and inclusive use of marine resources, which is vital for the food security of coastal communities. Future Oceans Lab shared research findings through leaflets, posters, and community conversations. Participatory workshops with fishing communities encouraged discussion and feedback on climate adaptation. Results were also shared widely via audiovisual media and a contemporary dance piece.